Hey, so welcome back. Today I'm going to do a brief video on osmosis, and it should be pretty short. Okay, so osmosis is simply the diffusion of water, right? The molecule H2O. Because water is so important to living things, we do give it its own name, osmosis, and there are some principles of moving water in and out of cells that make it a little bit unique, but for the most part, it's really just the diffusion of water in and out of cells. Okay? So water is polar, of course. And so that means that this water molecule cannot easily cross the membrane. Right? So simple diffusion isn't how water usually moves in and out of the cell. Water needs to have a protein channel to move. Right? So water uses facilitated diffusion for the most part. Right? There is a dedicated protein channel designed specifically to move water and just water. Okay? These channels are called aquaporins. Okay? And again, they move only water. Cells have a lot of these. Okay? So water very easily moves in and out of the cell through these aquaporins. Basically, water will always move with the concentration gradient. Okay? Nothing's ever holding water in and out of a cell. It can move freely across the membrane. Okay? Now, water, because it can move so freely, the direction of movement is more often regulated not by the concentration of water itself, but by the concentration of other molecules involved. Right? This gets very interesting and more pertinent when those other molecules are ionic, because ionic things can't cross the membrane. Right? And so water can move either way, no matter what, but these ions are stuck on whatever side they're on. Okay? And so obviously the more of other things that I add to an area, the lower the water concentration is going to be. Right? And so if I have 4 pieces of salt, or rather, let's start with water. I have 4 pieces of water, right? And I have 1 piece of salt, okay? That's 4 times water to salt. Now, let's pretend I have 4 pieces of water, same amount of water, but I got 16 pieces of salt. I now have 4 times as much salt, right? And so the concentration of water went down by like 16 times, right? I didn't change the amount of water, I just changed the amount of salt. And so the more I add of other things, the lower the water concentration is, even without changing the amount of water. Okay? And so water will move to try to balance this inequity of concentration from side to side, okay, even though the ions are stuck. So I have a few examples here. Okay? In my first example, I have 100% water inside the cell. Now, obviously, that's not a very realistic example, right? There's going to be other stuff inside of a cell if this is real life. But to make this super easy and clear, I said all there is inside the cell is water. Okay, so the concentration of water inside the cell is 100%. Right? Outside the cell is almost all water as well, except for this one ionic compound here. Okay, I got 1. Right? And so as long as it's not completely water, it's less than 100% concentration of water. Right? And so water is going to move down the concentration gradient. So it's going to go from where it's higher to where it's lower. Right? And so a water molecule is going to move out. But now inside the cell is still 100% water, and outside the cell is still less than 100% water. So another water molecule is going to move out. And it's just going to keep going out and out and out and out. That's it. It's never going to reach equilibrium because it can never balance under this circumstance. When you have more stuff outside the cell than inside the cell, right? More non-water stuff, that is hypertonic. Okay, hyper, I think of it being like big, large, energetic. It's more. Okay, and we're talking about the stuff, not the water, but the stuff. So hypertonic is there's more stuff outside the cell, and the water will move out of the cell to try to balance it. In this model, I have 100% water inside the cell, and I have 100% water outside the cell. When it's even, that's called isotonic. And the net movement's not going to be anything, right? It's going to stay the same. Water's moving out and in evenly. And then when I have more stuff inside the cell, more non-water stuff inside the cell, that's called hypotonic, right? And so inside the cell here, I have less than 100% water. Outside the cell, I have 100% water. So the water is going to move in. And the water is going to keep moving in and keep moving in and keep moving in and keep moving in. Now, the thing about hypertonic and hypotonic conditions for cells is that they change the health of the cell, right? So you can imagine this cell down here where the water keeps rushing in and rushing in and rushing in. That cell is getting full and full and full and full. And these cells have a limit to how full they'll get, and then they blow up like a water balloon. Okay, it's called lysing, L-Y-S-E. Okay? And so if you flood the cell with too much water, it blows up. The opposite is happening here, right? All the water is leaving the cell, so the cell is shriveling and sinking down, right? Getting all ploppy. Okay? So hypertonic and hypotonic conditions are not good for cell health. Okay? And that's basically it. That's basically osmosis. We're moving water through diffusion, facilitated diffusion specifically, through aquaporins. Because water can always move freely through these aquaporins, right, we are looking more at the other substances involved to try to determine which way the water is moving. Right? And so if we have like ionic substances that can't go into the cell and there's a bunch outside, the water is going to rush outside to try to balance that out. Okay? So like if you drink salt water, like your cells, your blood will be full of salt water, and the water, fresh water inside your cells is going to rush into your blood, bad for your cells, right? Make you dehydrated. That's why you don't drink salt water. It's bad for you. Don't drink the ocean water. You have a little salt water. Like, it's good for you. If you wake up first thing in the morning, you have a glass of salt water, it's really good because it gets your heart up and your blood flowing without having to dump your adrenal glands. So it saves your adrenaline for like later on in the day. Just a little pro tip. That's it. Osmosis done. Bye.